Hey folks, welcome back to another video. Today we're looking at question 406, Q reconstruction by height. The way we'll be approaching this problem is by using two layers of sorting. Coming up with a solution for this problem during an interview might be hard, but solving it on your own and being able to have some time to think about it and then solve it would possibly be better. But once you solve it, that method stays in your head. So hopefully that should help. So how would you come up with a solution for this, right? So this is an input that's given to us, right? And then if you just look at it purely from a numbers perspective and not really from the question, you will see that if you just look at a particular number, right? So the height of a person that's 7 and 7, you see that if you just look at these numbers, that they're sorted with the second digit. So 7, 0 and 7, 1. So they're of equal height, but they're sorted in the order of the second integer in the array, right? Same for 6. There's only one occurrence, so it doesn't really matter. But if you look at 5, this is also sorted, right? So 5, 0 occurs before 5, 2. And then 4, there's just one occurrence of that. So it's in somewhere, but we don't really care about that. So if you look at this particular example, you have, oh, nothing is repeated. So I guess that doesn't really hold. But since we know that these numbers are arranged first, at least if you look at the same height, it's arranged based on the second digit. And if we sort it that way, right? And then based on all of the other heights, you just keep adding it. So what we do is we look at the first height. We start on the decreasing order, right? So we start with the decreasing order and then we add the first number as is. And the second one, we look at all of the other numbers that start with the same height. So the first number is the same, but the second number is in increasing order. So basically the way you're arranging the numbers, like the array is a decreasing height, but increasing second digits and how many people are actually in front of you. Right, so you do that, you come with 6. 6 is less than 7, so you add it here, and you don't really care about that. 5 comes after 6, so you do that. And then you have another occurrence of 5 and 5, but 2 comes after 0, so you add it right after. And then 4 and 4, right? So this is sorted in the height order, and it says how many people of the same height, at least, are in front of you. But we need to take everything and aggregate and sort it. So how do we do that, right? So the way we actually do that is by using the second digit itself. So let me walk you through that, right? So you look at the first pair and you add it as is. The second pair, you add it based on this particular position. So it should be in the first place. So you just add it in the first position. And then you come to 6 and 1, and you see that this right here says 1, so you'll just add it to the first position. So what exactly does that mean, right? So when you've added all these three, you realize that this particular number says there's only one number before me that has a greater height. So if you just look at this array, right, it's already like a sub answer of sort. If this was a given array to you, this is sorted based on the requirements, right? And then if you see 5 and 0, it just has to be added in the 0th position. And then you add it here, right? And then you see 5 and 2, it has to be added in the second position. So you just add it in the second position, and even if when you add it in the second position, you still see that for this sub array, it's still sorted based on the requirements. And then the last one, 4 and 4, you add it in the fourth index. So if you check here, it's 0, 1, 2, 3, and 4. So why does this work, right? The reason why it works is because when you've sorted the order in the way that we talked about before, so first decreasing by height, and then if that doesn't work, if they are of the same height, and then you arrange it based on the number of people, the increasing order, so 0 and 1. And the way you use a position is because you say, if you look at 6 and 1, it says, hey, there's only one person who is taller than I am, but that value has already been added in the right position. So that's the reason why it works. So even if you say 5 and 2, there are only 2 people who are of the same height or of the greater height. So those two numbers have already been added here. Like you see right here. So these two numbers have already been added. So 5 and 0 and 7 and 0. So because those two heights have already been taken care of, you don't really have to worry about, oh, what position I need to put it in. You just need to look at the second number and just add it to the index blindly. Awesome. I hope that makes sense. So let's jump into the solutioning. Once you understand this approach, it's relatively simple to write the solution itself. So first we know that we need to sort the array in this particular order, right? So it'll be arrays.sort. You take the given array that's given to you, that is people, and given two values, A and B, you need to check a couple of things. If A of 0, if it is equal to B of 0, that means if they're of the same height, then arrange it in increasing order based on the second digit that you see. If not, then you arrange it based on the decreasing order. Yeah. Okay, so once that is sorted, you will have something like this. What you need to do is just create a list and add it in the right spot. So let's create a list. And the list will contain an int array. And then let's call it result, new linked list. And what do you have next? Right. So you need to iterate through all of them. So res.add, we just look at p of 1, and then you add p right there. And then in the end, you convert the result to an array. Right. Okay, so let's try compiling this and see if that works. The first test case looks okay. Let's submit it. Okay, that's awesome. So let's talk about the time and the space complexity of the entire solution, right? So the time complexity of the entire solution is O of n log n. And the reason why it is O of n log n is because we are actually sorting it here, right? So that's the reason why it's O of n log n. And this is the for loop is O of n, but since O of n log n overtakes n, the time complexity is O of n log n, and the space complexity is O of n. Since we are using a new list to keep a track of the order that we care about to return. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Please, if there are any other questions on LeetCode that you'd like me to solve, also please let me know in the comments below. I would really appreciate that. And don't forget to subscribe to the channel and like the video. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you all in the next video. Peace.